right, I'm going to record this as quickly as I can. I'll probably end up rambling on. For starters, since I'm not there, I figured I put a picture of me and Stan Lee up for you to look at. So, ray diagrams and real images. If you've been working on this and have been back in the lab at all and have been observing the real image, different than reproduction, you maybe have noticed a couple of things. First off, you probably have noticed that you can only see the image clearly at one point. Okay, and that is where the image location is. So we diagram that out on the paper, we move the screen around, you eventually find it for the setup that's at the back lab table. But if you go any closer to the lens or any further away, it becomes blurry. Okay, that's one way in which a real image is different than a reproduction. Your reproduction for the pinhole camera, when you move the screen back and forth, the size of the reproduction changed, the intensity of it changed, but you could always see it. That's not the case with the real image. The real image only exists at that one spot. Okay, another thing that you may have noticed, and probably the coolest part about it, is that you don't need the screen in order to see it. What the screen allows you to observe is the real image from many different locations. Because once the light that's forming the image strikes the screen, we get diffuse reflection, those particles spread out. You can see it from a lot of different locations. But if you take the screen away, it's not there. Unless you go behind the entire setup and look in through what we often refer to as the cone of light, the cone of vision, where we're able to capture some of the light that is forming the real image, and then you can see it like it is floating in space. If you haven't had the opportunity to yet, you should go to the other side of the classroom from where the image is being formed, identify it, and then slowly walk towards it, and you'll be able to see the depth from the image to the lens to everything else. You can almost reach out and grab it. Okay, so a real image forms in space, does not require a screen like a reproduction does. That's another thing with the difference between the two. If you take away the reproduction, then, or excuse me, you take away the screen for reproduction, you just see a pinhole of light coming through. You don't see anything. Here, you still see it. Okay. So a real image forms when real light particles converge together in a given point in space. And when they converge at that point, it creates the image. Okay, so there are some differences between the reproduction and the image. Okay, so one of the reasons why we wouldn't call what we saw with the pinhole camera an image, because reproduction requires a screen, an image does not require a screen in order to see it. A couple of other things that you should have done. If you haven't done parts 8 and 9 of this handout yet, stop watching the video and go and do them. Do this now. Okay, good, you're back. If you cover up various amounts of the lens, you can use open fingers. How do you think this will change the focus image? If you've done this, you'll notice that the entire image still forms. It's a little bit darker, and that should make sense because when you cover up the lens, you're blocking some of the particles from being able to reach that point, so the intensity of the light is less. But as long as there's still some of the lens exposed, you see the entire image. It's actually one of the coolest parts about the lens that we're working with, and we can talk about that more when I get back. And then the last one here, take an index card with holes punched in it. Move the translucent screen back and forth behind the lens. What do you observe? What do your observations say about where light from points on an object strike the lens? You should notice that you still only get one image. When we did this with the reproduction, we got multiple. With this, you only get one. There's really no difference between 8 and 9, okay, in terms of what's happening. You're blocking some of the particles, but many of the rest are coming through, but you're still only going to see one image forming. Okay, the last little bit that I'll leave you with is this lens that we are working with. If you've noticed in the diagrams, all the light that goes through it, those light particles converge. All the rays that you have leaving a given point on the object converge on the other side. That's why this type of lens is called a converging lens. Converging lens seems to form real images. Also known as, by the way, real images are also sometimes referred to as aerial images because we can see them in the air. So that's my 5 minutes. I'm done. You're done for the day. Important, big concept idea stuff here. If you have questions about any of it, email me. I will get back to you. And see you later.